You must have noticed traffic signals changing from green to amber and then to red. Sometimes it may frustrate you too, but do you know how traffic signal works? Controlled system to minimize the conflict of traffic movements. At each approach lane to a junction, there are 3 directions available for vehicular movements: left-turning traffic, right-turning traffic, straight-ahead traffic. It means at junction, the cross-movement of traffic takes place, and as a result conflict points are generated. For example, if there is a 3-legged junction, there will be 9 conflict points, and if there is a 4-legged junction, there will be 32 conflict points. That's why signal-controlled junctions are introduced. At the signal-controlled junction, traffic going in different directions can proceed in a controlled manner designed to minimize conflicts. Also, when the existing junction approaches to saturation level due to excessive side road traffic, which means excessive left turn movement or right movement, a signal-controlled junction is warranted. Traffic signal phasing. Signal phasing refers to the sequence of green, amber, and red signal timing. There is a variety of phasing measures that traffic engineers customize to accommodate various junction configurations and traffic volumes for each directional movement. Even the easiest option to make a left turn movement free or controlled takes a substantial amount of investigation and consideration. So now the question is how long a signal phase should last for one arm of the junction, and when the next phase should start for another arm of the same junction? This is actually dictated by signal cycle timing. What is traffic signal cycle timing? Cycle time consists of a minimum of 2 signal phasing, and goes up to a number of signal phasing depending on the number of traffic movements. Ideally, a green light for each phase of a junction should last at least long enough to clear the queue that built up during the red light. But it's not always probable, particularly during the peak times on a busy junction. So here, when the junction is saturated, the green light for straight movement may need an extension of each phase to minimize the startup and clearance times for a period where the junction isn't being utilized to its maximum capacity. What is the purpose of amber light in a traffic signal? Amber time is provided to alert drivers that the green interval is being terminated and red signal will be active. When a vehicle is quite close to the junction, it is easy for the driver to safely cross the stop line before the signal gets red. When the vehicle is quite distant from the junction, it is easy for the driver to safely stop the vehicle at the stop line when the signal gets red. But when a vehicle lies in the dilemma zone, it is a difficult situation for the driver to make a decision of stop or go. That's where amber light plays a very important role. The amber light should last long enough for a driver to observe the warning and brake their vehicle to a stop at a comfortable rate. Signal timing is primarily provided in 2 possible ways. First with a predetermined fixed signal timing method and second with actuated signal timing. In actuated signal timing, the signal receives the input from the signal controller unit situated in UTC center. Hourly traffic data are stored here, and the controller is set to make the decision to change signal lights and sequencing. In this system, traffic data are recorded via video cameras or radars or inductive loop sensors embedded into the road surface. Inductive loops are the most commonly used method for traffic data recording. Actuated signals can improve intersection capacity and operation when there is variability in vehicle demand. Actuated signals will trigger a phase when there is a demand for that phase with the help of a microwave detector and/or induction loop detector. In predetermined fixed signal timing, the traffic lights are fed with predetermined time, and they change to green, amber and red accordingly. This isn't a preferable method because it doesn't consider the real-time traffic situation. What I mean here is that the predetermined signal time is 40 seconds for a phase, and if there is no running vehicle after the 25th second, the signal will still stay green despite there is no demand. It is an ineffective use of the signal system. This system is inexpensive to install and needs very little maintenance. These systems are used primarily on low-traffic roads. Pedestrian push-button units for traffic signals. In urban streets, you must have seen pedestrian push-button units attached with signal poles. These units provide on-demand green time for the pedestrian to cross the road safely. Dropped curb units and blister tactile units helps blind, partially sighted and wheelchair users to press the button and cross the road when the signal becomes green for them. Technological advancement surely helps the traffic engineering community and traffic signal operators to operate and maintain the traffic movement of urban traffic, which is the backbone of our economy.
I hope this video provides you with adequate knowledge of the traffic signal design and its associated features. Please feel free to like, share, and comment.